Hello everyone. In the series of 8051, today let's try to implement one application that is remote car control. In the last session we have seen that DC motor interfacing. Let's assume, let's take a car which was connected to two motors. With the help of two motors I am trying to control this vehicle. Okay. Uh, for the controlling of the motor I am connecting 5 push buttons. Already I have taken required components. Totally I am taking 5 push buttons. First push button for move the remote car in the forward direction. Second push button for move the vehicle in reverse direction. Third push button for move the vehicle in right direction. Fourth one for left direction, and fifth one for stop the vehicle. So for the controlling totally I am taking 5 push buttons. And also I want to display the motor direction on LCD module. Already we completed LCD interfacing, so let me include LCD also. Actually individually you completed switch interfacing, DC motor and LCD interfacing. Now by combining all these three I/O modules, let's implement remote car. So that I am including LCD also. LCD, two control lines RS RW, three control lines are there, RS RW enable. So RW is always 0, so that I have connected to ground line, and remaining two control lines are RS and enable. Those two are connected to port 1.0 and port 1.1. So now we are operating push buttons in order to control the remote car. And also you can see the status on LCD module. So how, where, in which direction it is moving. Okay, this is the ground line from RW, which are the hardware connections. Accordingly we should write the code, right? So push buttons are connected from port 1.3 to 1.7 and 1.0 1.1, which are connected to RS and enable line. So when you are connecting inputs, we should configure respect to IO lines as 1. It is rule number 1. Okay, so let's assign the required pins. In our interfacing, port 3.0, 3.1, 3.2, 3.3, which are connected to motor driver input lines. Some I have given as M1, M2, M3, M4, and we have taken RS LCD module. Their RS, which was connected to port 1.0, and enable line connected to port 1.1. LCD 8 data lines are connected to port 2. And coming to the switches, S1, I'm giving the name as S1, which was connected to port 1.3. In the same fashion you are connecting remind 1.4, 1. Totally you have taken 5 switches. I'm taking the name as S1, S2, S3, S4 and S1. Okay, S1 to control the vehicle in forward direction, and S2 for reverse, S3 for right, S4 for left, and switch number 5 for stop the car. Okay, and switches are connected to port 1. Upper pins configure port 1 last 5 pins as input. Respective pins should be right as ones. That means port 1 equals to 1 1. Yeah, now you can check out from LSB to MSB, port 1.0, 1.1, 1.2. These three lines are configured as output, from 1.3 to 1.7 configured as input lines. So these are input which are connected to switches, means or push buttons, and port 1.0, 1.1, 1.2 which are configured as output, actually which are connected to LCD control lines. Okay, so after that, LCD initialization. In order to do that, we should send some commands to the LCD module. Already we have seen in the last class. A call command, 38 06 0C 01 command for the clear existing LCD, and this is for display string from first row first column. So on LCD module, I'm going to display the motor direction or car direction. So in order to do that, we should define text 1 dB. Car is moving in the forward direction. That in the same fashion, you can define totally 5 text messages. Text 1, text 2, 3, 4, 5. Reverse, right, left, and this is for stop. Okay, 5 messages. So all messages, starting message starts from 1000 location. That's okay. Okay, and so after LCD initialization, start the programming. So our role is keep on read the push button status. So now from the port 1.3, keep on it is giving logic 1. When you press the button, that 1 goes to ground terminal. If you press push button 1, before pressing the push button, at this point you will get 5 volts. But when you press the push button, these 5 volts are goes to ground terminal. Now at this point, if you read voltage, you will get 0 right now. So when you are reading the push button, if you get logic 0, which means the push button is closed. In case if you get logic 1, the push button is open. Okay, na? That is the key point. If you close it, you will get value as a 0. If it is open, you will get value as a 1. So in the programming, keep on we should read the all buttons. To read the push buttons, I'm taking the condition as a no bit. No bit means 1. If no bit on switch number 1, no bit means 0. If 0 on switch number 1, then jump to forward. Forward. Suppose switch 1 was closed, then it will jump to forward. There we should write the code for moving the car in forward direction. See, I have one table. So now port 3.0, 3.1, these IO lines are connected to motor driver input lines, input 1, input 2, input 3, input 4. Now At a time I am sending 8-bit value to the port number 3, right? So when you are writing 05 number to the port 3, then as per the input combination, the call direction will goes in the forward direction. Call direction in forward. If you send 1010 values, then it takes reverse direction. Then input 1, input 2 are in the clockwise, and second motor will rotate in the anti-clockwise direction. If those two motors are running in the reverse direction, then the vehicle will take right direction. And in this case, second motor running in the forward direction and first motor running in the anti-clockwise direction. Now the vehicle means car will take left direction. Right now, in this case, first motor is running in the forward direction, second motor running in the reverse direction. Now totally the car will take right direction. For this combination, first motor reverse direction and second motor forward direction. In this case, the vehicle will take left direction. To stop the vehicle, just simply send all zeros, which are the hex values. Directly I am sending all these values to the port 3. So for forward direction, what is the value? 05. Send here move port 3 comma hash 05 h. After that, display the direction on LCD module. So forward text message begin from 1000 location. Move data pointer comma hash. You can write text 1. After that, I'm writing a call trans. So already we have a subprogram for the command a call command. Let me write code for that command. Move LCD comma e. After that, operate rs and enable. So I have explained the LCD module in detail. So clear rs, so that it means you are sending, it will select command register. So to enable LCD module, we have to send hypers and locals. Logic 1 and logic 0 with some time. Okay, so in this one you are sending logic 1 a call delay. Okay, a call delay, so it will be transferred to delay subprogram. Then L1 I'm writing this. So this is subprogram for the delay. After come back from subprogram, it will be returned to command. It is also subprogram. Then clear enable. Okay, so to enable LCD, write logic 1 and logic 0 with some time delay. Here you are sending logic 1. This is the time delay and this is the active locals. Subprogram is over. Then return. Okay, a call runs. So forward direction, you are sending 05 number, and after that you are taking text related to forward and a call trans. Trans. Here, in order to fetch the characters, clear accumulator. After that, you can fetch the characters. We have a statement as move a comma at the rate of a plus data pointer. It is the command to get text from the code After that, in the text as a end of the string, we mentioned 00. At last, if we get 0, if we get 0, jump to um, jump to next. If it is 0, jump to next. If not, a call send. If it is 0, jump to next. Somewhere I will written as next return. Okay, so from here I'm getting the first character. If it is 0, jump to next, otherwise a call send. So program will come to send. Somewhere you will get some program as a send, same pattern, set bit rs. In this one you're selecting data register. You know that LCD having two registers, command register and data register. Then enable LCD. Sometime later. That's it. So these three lines are for enable LCD module. This is a program. So that return. Okay. So now you got one character. Suppose first character is forward. Actually, you take in forward. After that, at the end you have a 00h. It is out of the double quotes. Okay. Now you are getting f character. F is non-zero. So that jump to, sorry, f is non-zero, so it will comes to a call send. Here you have sent one character. Okay. After that increment data pointer in the same fashion. In the same fashion you can get remaining characters also. Short jump to trans. Okay. So in this fashion you can send all the characters. At last finally you will get 00. When it gets 00, it condition comes to true. If the condition is true, jump to next. It will come here. Return to main program. Actually it was transferred from here. Okay, I call trans. So we have checked the switch condition here. If it is true, means if you press push button 1, it will come to forward. You are rotating the vehicle in the forward direction, and later you are trying to display call direction on the LCD module. Okay, so condition over. Then jump to or short jump to read the condition. Here you are reading the condition, switch condition. Okay, suppose if you not press first button, then check out second button. Jump if no bit on second switch, then go to reverse direction. In case if you press, if you not press switch 1 switch 2, then check out the switch number 3. It is for right. In case if first three buttons are not in the down, then check out fourth switch. If it is true, if you press fourth button, then jump to left. In case if you press last button, switch number 5, then stop it. In case if you not press any switch button, then repeat the same action. Jump to read. So from here you are checking switch by switch. First switch, if you press the first switch, it will goes to forward direction. In case if you press second switch, it will goes to reverse. Now write the code for reverse direction. To move the car in the reverse direction, what is the value we have to send? 0A. Send 0A number to the, so actually this will repeat. Send 0A. And what is the text number? It is text number 2. Same, nothing, there is no difference at all. Next one is right condition. So to move the vehicle in the right direction, for right direction, what is the value? 09 is there. Now send 09 number and text number 3. At the end of the code you have a different text messages. Okay, next one is the left. For left direction, what is the value? 06. Now take 06 number, and to stop the vehicle, text number 4, and this is text number 5. To stop the vehicle, send all zeros. That's it. I hope so. Let me check out on the simulation. So code seems to be like a somewhat lengthy, but if you understand the logic, it becomes very simple. Okay, and so I already have created project. Combine leave character in the numeric constant. Okay, so mention this one as double quotes. Comment section. Move port 1 comma hash 0f8 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 h. I forgot to mention h as x value. Okay, so no errors. Create text file and give the option as suppose car 123. It's my create file x file name. One more time. Okay, one to upload x file. Okay, let's check. Yes, it is moving in the forward direction. Okay, now when I'm trying to press second button, you can see the motor direction, car direction, and also you can see the same status on the LCD module. Reverse, it shows from the end of the LCD, but motors are running. Yeah, so let me modify in the coding section. So actually, before sending every character, you should clear LCD module. Yes. So after sending every string, we have to clear LCD module. Okay. That's why here move a comma hash 0001h and a call command. So this is the command is used to clear existing data on LCD module. Okay. Now let's copy the code. Automatically X file will update here. Forward, running in the forward direction. Yes, clear the LCD module, and the two motors are in the reverse direction, so that the car will move in the reverse direction. And right, so first wheel is running in the forward direction, second wheel running in the reverse direction, so that the vehicle will move in the right direction. Now left direction, and if you press last button, it will stop. Fourth left and fifth button for stop. Okay, again if you press first button, forward, stop, reverse, stop, right, and then stop, left, and then stop. Okay, so you should analyze the concept. If you understand the concept very clearly, coding part will become easy. So I hope you enjoying this code and a small application. Thank you.